Hi guys, welcome back to part 2 of my lesson on pyramids and cones, finding the volume of pyramids and cones. Okay, for starters, it's very important to recognize when to use which formula. We just talked about the fact that there are two different formulas, okay? There's the formula that we've been using, which is area of the base times the height. And you use that if you have a matching top and bottom. So if it has a matching top and bottom like this guy, okay, then you use that formula. This also has a matching top and bottom. This, even though it's a triangle, it still has a matching triangular top, triangular bottom. So it has two triangular bases. So that's also that formula. Matching bases with a uniform height connecting them. So when you have a prism or a cylinder, they use that formula because they both have matching bases and a uniform height. Okay, so that's what we were doing up to this point. Well, now we're going to deal with solid figures that come to a point like these, okay? Pyramids and cones, okay? Pyramids are named by their base. So this is a square pyramid. This is a triangular pyramid. But you can even have a hexagonal pyramid and all kinds of things. Okay? This one's a cone because it doesn't have triangular sides like a pyramid does. But because they come to a point similarly, their formulas are also the same. Instead of this formula, if it comes to a point, the volume is only a third of that volume. So anything that has a point like this, your formula for volume is still area of base times height, but it's a third of that. So it's 1/3 times area of the base times the height. Or if it's easier, area of the base times the height divided by 3. It gives you the same thing. So those are your two formulas. You may want to take a screenshot of this or write this down. And the main idea here is you got to keep track of when to use which formula. Today we're just going to do the ones that come to point, so it's not going to be hard to keep it straight. In the future, you'll have to know the difference between when to use this formula and this formula, okay? Also, just the same as with prisms and cylinders, you're going to need some old area formulas, and you could have more than this involved. I just know I already wrote the worksheet. These are the only area formulas we're going to use. So let's get started. I'm going to work out some problems now, and just so you know what to expect, I'm going to work out this lesson worksheet, and if you want to, you can print it out or you can just follow along. Then after I'm finished with this lesson, you're going to do and you're going to turn in this worksheet. Okay? So I'm going to work these problems out for you right now. And remember, our formula for all of these, because they all come to points, your general formula for all of these problems is volume equals 1/3 area of the base times the height. Okay, so let's get started. The first one is a square pyramid. Not that it really matters, but the base is a square, and the area of that square is 10 times 10. So the area of the base is 100. The height of the pyramid is 12. So putting it all together, the volume is 1/3 area of the base times the height. Now, to figure this out, remember, multiplying by 1/3 is the same as dividing by 3. So you have two choices. You could multiply 100 times 12 and then divide by 3. Or if this is a non-calculator question, if either of these two numbers can be divided by 3, that's easier. Just don't divide both of them by 3. That would be like dividing by a ninth. So I'm going to do 12 divided by 3, which is 4, times 100 is 400. And it's still volume, so it's kilometer times another kilometer, kilometers cubed. Okay, so let me make sure you can see that. I better make it a little smaller. Okay, so that's that. You still do capital B times H, area base times the height, but divide by 3 when you're done. All right, so the next one's pretty much the same deal. It's a rectangular pyramid because the bottom's a rectangle, no big deal. Area of the base is still 6 times 8, which is 48. The height of the pyramid is 9. So the volume is, don't forget, 1/3 area of the base times the height. I can do 1/3 of 48 or 1/3 of 9, whatever's easier. Or I can multiply these two numbers together and then take 1/3 of it. Okay, so go ahead and figure that out, whichever way you think is easier. I'm going to do 1/3 of 9. 9 divided by 3 would be 3. And then 48 times 3 would be 144 cubic centimeters. Okay, pretty straightforward, I hope. The next one is still a pyramid because it comes to a point. But notice the base, I hope you can visualize this. The base is a triangle. So this is a triangular pyramid. So the base is a triangle, and the formula for the area of a triangle is 1/2 base times height. Okay, so just doing the triangle is 1/2. Only look at the triangle right now. Only looking at the bottom. I need to find the base and the height of that bottom. Ignore the height of the pyramid for now. Well, the base and the height of that pyramid, or that triangle, remember the base and the height have to be perpendicular. So where that right angle is, one of these is the base and one of them is the height. So I have a base and a height of 4 and 3, and it doesn't matter which order you use. So this 5 is just to throw you off. It's messing with you. So it's 1/2 of 4 times 3. So 4 times 3 is 12, divided by 2, that would be 6. Or 1/2 of 4 is 2, times 3, still get 6. So the area of the triangular bottom, this thing right here, okay, that area right there is 6. The height of the pyramid is 9. Putting it all together now, the volume of the pyramid is 1/3 area of the base times the height. Okay, well, 1/3 of 6 would be 2. 2 times 9, that would be 18 cubic inches. Okay, so same formula. The only thing that was different on that one is that the base was a triangle, and the formula for a triangle is 1/2 base times height. Okay, next, it still comes to a point. It doesn't have the same name, but you can treat it the same. This is a cone, but because it comes to a point, my formula is still 1/3 area of the base times the height. So the base is a circle, and the formula for a circle is pi r squared. The height is 22. Okay, now I gotta look at the directions and see, am I gonna leave pi as pi, or do I change it to 3.14 or use the pi button on my calculator? Well, if you look at the directions, if it says round to the nearest hundredth, then typically you use 3.14 or the pi button on your calculator, which is what I'm gonna do. All right, so the area of the circular bottom would be pi, in this case 3.14 or the pi button on your calculator, times 11 squared. 11 times 11, which is 121. Okay, so this is pi times 121. Put that in my calculator, 121 times the pi button, and it's 380.13. This is very messy. 0.13 if I round to the nearest hundredth. Now, that's just the area of the bottom. To find the volume, it's 1/3 area of the base times the height. Put all of that in my calculator. Okay, so I'm going to do this number, which in all honesty, I should leave the number as it was in my calculator, but it's not going to matter if I round too soon on this. I'm going to do this times 22 and then divide by 3. So this number times 22, divide by 3, or multiply by a 1/3. So the final answer is 2,787 point. It says 639, but the direction said to round to the nearest hundredth, so that should be a 0.64 at the end. Okay? Cubic inches. All right, last one. The only difference between these last two is how you're going to write your answer. In this one, it said round to the nearest hundredth. This one is still a cone, but the directions say to leave your answer in terms of pi, which is really more common for a high school geometry class. So here we go. Area of the base, still a circle, still pi r squared. Okay, well, the circle, we need radius, but what's given is diameter. So if the diameter is 4, then the radius is 2. So the area of the base would be pi times 2 squared. 2 squared is 4, so that's 4 pi. This time I'm going to leave it 4 pi. I'm not going to change pi to 3.14 because of these directions. The height of the cone, even though it's laying sideways, the height is 9. So the volume is 1/3 area of the base times the height. Now, you could just multiply these numbers together and tack on a pi at the end. Okay, I can still do 4 times 9, which is 36, and then divide by 3. Or if it's easier, I can do 1/3 of 4 or 1/3 of 9, whichever one's easiest. I'm going to do 1/3 of 9. 9 divided by 3 would be 3. 3 times 4 is 12. So this is 12 pi. 12 pi cubic inches. Okay, so I hope that that worked for you. Please feel free, guys. Feel free to email me if you have any struggles. The worksheet you're going to do that looks just like this is called Worksheet 3, the lesson. You're going to do Worksheet 3, the practice. Good luck. Hope you're all doing well.